Quit playing. So this says, in Matrix C, the entries are the numbers of students on a committee. Column 1 lists girls. Column 2 lists boys. So this is column 1, which is girls. Column 2 is boys. Column 1 is girls. Column 2 is boys. Row 1 lists sophomores. Row 2 lists juniors. Find A subscript 12, A subscript 21, and A subscript 22 and tell what each number represents. So A subscript 12, A subscript 21, and A subscript 22. I want you to make yourself a note. Subscript lists row and then column. So row and then column. Let's look at this. We want to find row 1. This would be row 1. Y'all agree the top row is row 1? Top row is row 1. The number 2 represents the second column. So first row, second column. So A subscript 12 represents 5 sophomore boys. A subscript 21. So that means row 2. So we're not even worried about that top row. Row 2, first column. That's the number 8. The number 8 represents 8 junior girls. And A subscript 22. Second row, second column represents 10. I was going to write subscript for some reason. 10 junior boys. All right. It says in Matrix C, the rows represent prices for shirts and khakis. The columns have the same meaning as in example 2. I don't know what example 2 meant, but we'll. If the sales tax rate is 6%, use scalar multiplication to find the sales tax for each item. Not the total of each item, just the sales tax per item. I'm probably assuming it's going to be like men's, women's, and children's or something, possibly. I don't know. All they want us to do is they want us to take 0.6 and multiply it by C, okay? So I've got 0.6, and I'm going to use scalar multiplication. And all that means is you're taking not 0.6, it should be 0.06. And I'm multiplying it by 75. I'm multiplying it by 100, 40, 60, 25, and 30. So I'm going to get my calculator, and I'm going to multiply 0.06 times 75. And I get 4.5. But if we're talking about money, that would be 4.5 what? 0, correct? So now I'm going to take 0.06 and multiply it by 40. And I get 2.4 or 2.40. 0.06 times 25, and I get 1.5 or 1.50. 0.06 times 100 gives me just 6. 0.06 times 60 is $3.60. And 0.06 times 30 is going to be $1.80. So all I did was I took 0.6 and basically distributed it to every single thing on the inside of that matrix, okay? Is everybody okay with how I got example 2? Yeah. All right, the next part we're going to use our calculator to help us do this. So I'm going to rename these instead of M and N. I'm going to rename these A and B. So anywhere I have an M, I'm going to put an A. And anywhere I have an N, I'm going to put a B just to make it easier because of what's on our calculator. A, B, and then B. Okay, you're going to have to pay close attention to my keystrokes here so that you can follow along on your calculator, okay? You're going to hit the blue button and then the button under math. It's highlighted red now. Do y'all see that? It's going to be like x raised to the -1 power. Do y'all see that? Okay, do you see? It should look like this. Is everybody on this screen? I want you to go over to edit because we're going to edit A. We have a 2x2 matrix because it is 2 rows and 2 columns. And I'm just going to input my numbers. For A, I've got -3. Once I type in -3, I'm going to hit enter. Then I'm going to hit 5, hit enter. 2, hit enter. 0, hit enter. So that should fill out matrix A for you. Now we're going to go follow those same steps. Second, and then that x to the -1 button again. But instead of editing A this time, we're going to edit B. Again, it's a 2x2 matrix. 6, enter. 5, enter. -8, enter. 0.2, enter. So from here, we're going to hit that second and negative, or x to the negative 1 button again. We're adding a plus b. So I'm going to hit enter on a. Whoops, not right there. All right, let's go back. Hit second and then mode. Second and then mode. Second mode. Hit second mode. All right, it doesn't matter what screen you're on, you can hit second mode. Now hit second and then that x to the negative 1 again and hit enter. And this should pop up. Did that pop up for everybody? All right, we're adding a plus b, so I'm going to do the same thing, except for this time I'm not going to choose a, I'm going to choose b. You hit enter and it tells you what your answer is. So when we added together a plus b, we got 3, 10, negative 6, and 0.2. So I know there's not hardly any room for you guys, so I wrote mine up here. A plus b, I got 3, 10, negative 6, and 0.2. Next thing they ask us to do, and so now once we have all this in, we don't have to go back and hit edit anymore. Now they want us to add together b plus a. So we go back to our calculator, and again we just hit second matrix, and this time I'm b plus a. So the same steps we just followed to get a plus b. And you hit enter, and you should get the same thing. So again, we got 3, 10, negative 6, and 0.2. All right, now what they want us to do is they want us to subtract a minus b and b minus a. So again, we're using those same matrices, so we don't have to edit anything. I keep hitting the wrong thing. All right, so we're starting with a minus b. And we get negative 9, 0, 10, and negative 0.2. We'll do the same, except for now we got b minus a. And it's the same numbers, but notice that some of the signs did change, okay? Now we've got 9, 0, negative 10, and positive 0.2. All right, consider the matrices below. Again, I'm going to change the names of these. A, B, and this time we've got C. So R minus Q would be C minus B. So I'm going to go second and then x to the -1, and I'm going to edit all of my matrices. So I've got a 3. No, I've got a 2 by 3. Rows, then columns. 2 by 3. That'd be 3 rows, 2 columns. So we got 5. Yeah, 2, -3. Uh-oh, what did I do? 5, 2, -3. 7, 0, 5. Alright, and I'm going to edit matrix B now. And it is a 3 by 2 because it is 3 rows and 2 columns. Now I'm going to also edit matrix C, and it is also a 3 by 2. Oh, what did I do this time? 6, 0, -3, 0, -2, and -2. Alright, so once we have all that filled out, they are asking us to find C minus B. So second, and then we go to our matrix again, C minus B. C minus B, matrix C minus matrix B. And I get 4, 2, -8, 5, 5, and -9. So let's see, we've got, I'm going to try to write it in here. 4, 2, -8, 5, 5, and 9. And then what other matrix sum or differences can be calculated? So let's try to add together A plus B. So I'm going to have matrix A. Ooh, I don't know why I did that. Matrix A plus matrix B. And you get this. You get an error message that says dimensions mismatch. The reason we get that is because A is a 2 by 3 and B is a 3 by 2. They have to be the same exact dimensions in order for you to They have to be the same exact dimensions in order for you to add or subtract, okay? That never fails. They have to be same dimensions in order for you to add or subtract. So, if that's the case, there's only 4 different options I can do here. We've already subtracted C minus B, but we'll be able to add C plus B. We could subtract B minus C, and we could also add B plus C. The reason we are able to do that is because B and C are both the same dimensions. A's dimensions are 2 by 3. B and C's dimensions are 3 by 2. Now they talk about the additive inverse. What could we add to each matrix in order for it to equal 0, basically, is what they're asking. To find the additive inverse of A, B, or C, all you do is you use scalar multiplication. Use scalar multiplication and multiply each matrix by -1. So for A, the additive inverse, which would be -A, you just multiply everything inside by -1. So -5, -2, +3, -7, 0, and +5. So I just multiplied everything on the inside by -1. I'll do the same for the additive inverse of B. -2, +2, -5, +5, +7, -7. And then -C. -6, -0.5, 3, 0, 2, and 2.
It's 4.
Oh, I thought I said 2 plus 2. And then this is a good, I know we don't usually fill this out, but this is a good thing for you to fill out here. What must be true about two matrices for their sum and difference to exist? Their dimensions must be the same. All right. Use matrices to translate and dilate figures. A segment has the endpoints of 8, -7, and 1, 2. So using a matrix, I'm going to write those segments as 8, -7, and 1, 2. We want to translate. So when we're translating, we add. Use matrices to represent the translations of MN to RS so the segment MN to the segment RS by 6 units left and 3 units down. 6 units left. If we're thinking left, that would be negative. To move it left, we would be moving it negative. To move it 3 units down, we would also be moving it negative. So -6 units left, so -6. 3 units down, so -3. We have to do it for both columns so that we can add these two matrices together. So now they want to know our coordinates for R and S on the coordinate plane. I know we've been letting our calculator do all the work for us, and you don't really know how we are adding things here or subtracting things, but it's very simple. To figure it out by hand and not put it all in the calculator, you would say 8 plus -6. So you would add together or subtract together the two terms that were in the same spot of each matrix. So 8 plus -6, and what do you get? You get 2. All right, next I would say 1 plus -6. And you get -5. Next I would say -7 plus a -3. And I would get -10. And then last, I would say 2 minus 3, and I would get negative 1. So do you see how I'm adding it, or I would subtract it with the same in the same spot of each matrix? So this tells us our coordinates. This is our coordinates for R. This would be our coordinates for S. So my coordinates for R, I write as 2, negative 10. My coordinates for S, I write as negative 5, negative 1. All right, use matrices to represent a dilation by a scale factor of 3. We just use that scalar multiplication. So we have 8, negative 7, because we're still using MN, and 1, 2. 3 times 8 is 24. 3 times negative 7 is a negative 21. 3 times 1 is 3. 3 times 2 is 6. What are the coordinates for D and E? My coordinates for D would be 24, negative 21. My coordinates for E would be 3, 6.